This is the second video in section 5.8, which covers exponential growth and decay models. This is one more model to look at and is known as the logistic model. And the reason for it is this idea right here. This formula that we dealt with in the last video assumes uninhibited growth. So cell division can be modeled by this function, but that assumes that no cells die. So cell division is limited by space and food supply. And it's not just cell division, population growth is also limited by space and food supply. So the logistic model can describe situations where the growth or decay of the dependent variable is limited. So here is the function for the logistic model. P of t equals c over 1 plus ae to the negative bt, where a, b, and c are all constants, and a is greater than 0, and c is greater than 0. So let's take a look at one example. The logistic model P of t equals 92.1478 over 1 plus 0.0322e to the 0.1828t represents the percentage of households that do not own a personal computer t years since 1984. So it asks us, first off, to figure out what is P of 0. Well, P of 0 is a matter of just substituting 0 in for t and doing this arithmetic. So this is just a calculator problem. But we can make the entry in the calculator a little bit easier by remembering that anything to the 0th power is 1. So 0.1828 times 0 makes all of this become 0. E to the 0th is just 1. So this just boils down to entering in your calculator this, 92.1478 divided by 1 plus 0.0322. But you need to put the 1 plus 0.0322 in parentheses so that you're dividing the numerator by the quantity 1 plus. And when you do that, this works out to be 89.3% rounded to the 10th place. So P of any value is a matter of plugging it into your calculator. This was just very easy to plug in because it was 0. Now what does P of 0 represent? Well, remember, we are looking at this percentage of households that don't own a personal computer t years since 1984. It's kind of like time began in 1984. So P of 0 would be the percentage of households, we'll call them HH to save time, the percentage of households without a computer in 1984. Now it asks us, what percentage of households did not own a personal computer in 1992? Well, first off, we have to think about that 1992 is 8 years since 1984. So in this case, t equals 8. So it is another calculator kind of problem that we've just got to be sure we enter correctly. So we're doing P of 8, and it equals 92.1478 divided by, and I'm going to go ahead and put the parentheses there so I don't forget it with my calculator, 1 plus 0.0322, let's get rid of this that I erased, e to the 0.1828 times 8. Close your parentheses, and that's all you have to enter in the calculator, and this works out to be 80.9%. And a word about order of operations. You may be tempted to look at this and call that 1.0322 times e, but remember, order of operations says you must multiply before you add. As a matter of fact, you must do exponents before you multiply. So if you really had to do this by hand in order, you'd have to do e to this power, then times the 0.0322 plus the 1. Of course, your graphing calculator does the order of operations for you. I just want to warn you not to write this as 1.0322e, because that's not the case. So now let's use this information to find out in what year will the percentage of households that don't own a personal computer reach 15%. Now, the 15% is actually what's going right here. And we're trying to find out in what year, which means we first have to find t. So we're doing 15 equals 92.1478 over 1 plus 0.0322 2e to the 0.1828t. And we just have to solve this equation. Now, it's a little more complicated than the ones we did in the last episode. So what I like to do is to think about cross multiplying here. So if I multiply 15 times this whole bottom, now I'm not going to distribute. I'm leaving it as 15 times the quantity, 1 plus 0.0322e to the 0.1828t. And that equals 92.1478. Now remember what we're trying to do. We're trying to get t alone. So the first thing I do now is, instead of distributing, this is 15 times this quantity. So let's divide both sides by 15. So on the left side, it's 1 plus 0.0322e to the 0.1828t. And then with your calculator, you can do 92.1478 divided by 15, and it is approximately 6.14. Leave the whole number on your screen, but this is about 6.14. The next thing I would need to do is subtract 1 from both sides. So on your calculator, you can subtract 1 from this number, which will now be 5.14, etc. Leave that whole number on your screen. And over here now, the 1 is gone. This is 0.0322e to the 0.1828t. Still don't have the e isolated. To solve these exponential equations, you must get the exponential part isolated. So I need this part isolated. And the way to do that is to undo this 0.0322 times this. So let's divide both sides by 0.0322. Now remember, you have this whole number on your screen. So all you have to do is hit divided by 0.0322, and this is approximately 159.7. Again, that's not exact. Leave that whole number on your screen. And now this is e to the 0.1828t. So what we've done so far is just done some algebraic steps to get the exponential part of the function isolated. Now we can get rid of the exponential idea by taking the natural log of both sides. Of course, ln e is going to give me, I'm coming up here, 0.1828t equals, now to do the natural log of 159.7, I have 159.7, etc. on the screen. I can do natural log and then hit second answer, and that means the calculator will access this whole number that you've got sitting on your screen, and that comes out to be about 5.07. Again, leave the whole number on your screen, and our last step now to get the t alone is to divide both sides by 0.1828. So you've got this 5.07 big number on your screen, divide by 0.1828, and t comes out to be about 27.8 years. Now, we're not finished. We have to take this 27.8 years and add that on to 1984, because it asks during the year, in what year, which would mean during the year. So if you add 27.8 to 1984, that's going to give you sometime during the year 2011. So in the year 2011, we're going to end up with 15% of households that do not own a personal computer.